We now discuss the solution of a problem from the section Linear Algebra. This problem has appeared in the CSIR National Eligibility Test held on 16th September 2022. And the problem is related to the rank and nullity of a given linear transformation. And this question is from part C. The given question is, let V be the vector space of polynomials f of x comma y, where x and y are variables. That means it is the vector space of polynomials in two variables x and y that belongs to the vector space of all polynomials in two variables x and y over the real field R with total degree less than 3. Let capital T from V to itself be the linear transformation given by the partial derivative with respect to x, that is dou by dou of capital X, that is del by del of capital X. Then which of the following statements are true? We are given four options. Option A, the nullity of T is at least 3. Option B, the rank of T is at least 4. Option C, the rank of T is at least 3. Option 4, T is invertible. We are given the vector space of all polynomials in two variables x and y that are coming from the vector space of all polynomials in two variables x and y over the real field with the total degree less than 3. Agreed. And T is a linear transformation from the V to itself defined by dou by dou of x, that is the partial derivative with respect to x. Then we have to discuss which of the given four statements are true. That means there can be more than one answer. Right. We now discuss the solution of the problem in detail. We have V, the vector space of all polynomials in two variables x and y belonging to the vector space of all polynomials in two variables x and y over the real field R with degree of fxy is less than 3. The total degree less than 3. It is less than 3 and it is a vector space. V is a vector space over R. That is, V is the set of all polynomials in two variables of the form a0 plus a1x plus a2y plus a3x square plus a4xy plus a5y square, where the total degree is less than 3, that is 2, we have written is less than 3. This is the typical polynomial of degree less than 3, where the coefficients ai are all real numbers for I is equal to 0, 1, 2, 3 up to 5. Agreed. Now B is equal to the set consisting of 1 x, y, x square, xy, y square is an ordered basis of the vector space V over R. Agreed. Then we can find the dimension of V. The dimension of V over R is equal to the number of elements present in a basis B. There are 6. So the dimension of V is 6. Given T from the vector space V to itself is the linear transformation defined by T of f of x comma y is equal to dou by dou x of f of x comma y. So take the typical f of x comma y and differentiate partially with respect to x. We continue in the next slide. So that's what we have. Now let's now compute r suffix t, that is the notation for range of t. Range of t is the set of all images of the polynomials under the linear transformation t, that is the set of all t of f of xy where f of xy belongs to V. So that will be equal to, t is defined as dou by dou x. Dou by dou x of the typical polynomial f of x comma y where f of x comma y belongs to V. That is the set of all dou by dou x of the typical polynomial a0 plus a1x plus a2y plus a3x square plus a4xy plus a5y square, where ai's are real numbers for I is equal to 0, 1, 2, 3 up to 5. When you differentiate, is a set of all polynomials of this type. Dou by dou x of a1x is a1, the dou by dou x of a0, the constant, is 0. The dou by dou x of y is 0. The dou by dou x of x square is 2x. Dou by dou x of xy is y. And dou by dou x of y square is 0. So you will get a1 plus 2a3x plus a4y. ai belongs to R. I is equal to 1, 3, 4. So now the range of t is generated by 1, x, y, and that will be the basis for RT. So the B prime is the set consisting of 1, x, y is a basis. Why? The 1, x, y is a linear span. You see, the linear span is the linear span of 1, x, y, and they are linearly independent. Therefore, it's a basis for RT. Therefore, the rank of T is the dimension of the range, that is equal to the number of elements present in a basis of RT, that is B prime, that is equal to 3. Right. The dimension, the rank of T, we got it. Let's look at our options. And in this, the reference for rank of T is there in option B and option C. So the rank of T is 3. Option C is true and option B is not true. So the option C is true, option B is not true. Agreed. Having known the rank of T, we can find out the nullity of T by using the rank nullity theorem. So by rank nullity theorem, the dimension of the domain space, that is V over R, is equal to the rank of T plus nullity of T. The dimension of the domain space is 6 and the rank of T is 3. So we'll get 6 is equal to 3 plus nullity of T. That will imply nullity of T is equal to 3. And in this, the reference for nullity is given in option A and is at least 3. So therefore, this is also true. Option A is true. Now, what about the option 4? T is invertible. We'll say that T is not invertible. Why? Because the nullity of T is 3, which is not equal to, nullity of T is not equal to 0. Therefore, it is not invertible. So the option D is not true since the nullity of T not equal to 0. That means T is not invertible because nullity of T is not equal to 0. Why? Why it is so? Let's recall this one. T is 1, 1. T is a 1-to-1 transformation if and only if the null space of T is trivial, namely consisting of the 0 polynomial alone. That means T is 1, 1 if and only if the dimension of Nt is equal to the dimension of the 0 space. The dimension of 0 space is 0. The dimension of Nt is nullity of T. So T is 1, 1 if and only if the nullity of T is equal to 0. That means T will be 1, 1 when nullity of T is 0. but the nullity of t is 3, which is not 0, therefore it's not 1, 1, therefore it's not bijective, therefore it is not invertible. So that's the reason. That is the reason. So option D is not true, since the nullity of t is not equal to 0. So there's the answer to this question is option A. Option A is true because nullity of, so, and option C is true and the remaining two are false. So the answer to this question is options A and C. That is the detailed discussion of the solution of the problem from the linear algebra, which is based on the concepts of rank and nullity of a given linear transformation. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.